All right, you are welcome to this class. In the previous class, we looked at direction cosines of vector of any vector. So in this section, we'll be looking at how to find the direction cosines of a vector, right? Good. So let's look at how to work those examples out. Now, if you could remember that in the previous class, given a position vector u as xi plus yj plus zk and its modulus, that is magnitude, as the square root of x squared plus y squared plus z squared, right? Good. We concluded that we said direction cosine is given as, for the first unit vector, x over its modulus. Then we also said that the direction cosine for the unit vector along y-axis is given as cos beta, which is what? Y over its modulus. Then we said the direction cosine of the unit vector along z-axis is given as z over the modulus of the position vector. So in the first example now, we are going to be going by that, given vector A, which is what? 4i plus 3j minus 5k. So the next thing for us to do is to obtain its what? Modulus. So modulus of this vector will be given as 4 squared plus 3 squared plus minus 5 squared. So that in turn gives us what? The root of what? 16 plus 9 plus 25. And that gives us what? That gives us root what? Root 50. So if this is root 50, we've obtained the modulus of the vector. So the next thing for is to obtain the direction cosine, right? Good. So the direction cosine for this vector will be, for the first unit vector along x-axis, because alpha give us, that's 4. You can see along x, that's 4 over root 50. Then the direction cosine along of the unit vector along y-axis, that will give us 3 over root 50. Then the direction cosine along um, of the unit vector along z-axis is using as cos gamma equals what? Minus 5 over root 50, right? So this is basically the same as 4 over 5 root 2. Then it's also the same as 3 over 5 root 2. While this one is basically the same as what? Minus 1 over root 2. So let's come to B. Example B. Also, we have vector B to be given as I plus 7j minus 11k, right? So let's obtain the magnitude or the modulus of the vector, which will give us what? The square root of what? 1 squared plus 7 squared plus minus 11 squared. So that gives us what? The square root of what? 1 plus 49 plus what? 121. So that gives us what? The root of 171. 171. So again, if you are looking for the direction cosine for this position vector B along the axis of the unit vector, so we have here, we have cos alpha to be equal to what? 1 over root 171. Then cos beta to be equal to what? 7 over root 171, then cos gamma to be equals to what? Minus 11 over root 171. So I hope with these few examples, you've been able to um, know how to find direction cosines of a vector. You understand how to find the direction cosine of a vector. Thank you very much, class.